G'day and welcome to another one of my videos. In this video we're going to focus on sketching quadratic functions. And when we sketch those they form the shape of a parabola, so that's why we're referring to it here as sketching parabolas, but we also call them sketching quadratic functions. We're talking today about y equals ax squared, so some number multiplied by x squared, and we're going to have a look at what those parabolas look like. So what we'll do is we'll start off with the most basic of quadratic equations, and that is the quadratic equation just y equals x squared. To do this, we're just going to complete a table of values and see what happens, because we're probably used to looking at a table of values and plotting those points to see what the line or curve looks like. So here's our table of values. And we're going to substitute in each of these x values into this quadratic equation here, and then we're going to square them and see what our result is, and that will be our y value. So what we have to be careful of is substituting in negative numbers. And to do that, we're actually going to use the aid of a calculator to help us, and I like to use the Casio calculator. And you can see here we've already got a squared button. That's going to help us. But as I said, we have to really be careful of squaring the negative numbers, especially on our calculator. When we do this, I like to say that we use our brackets or grouping symbols, and we substitute in -3 and close our brackets or grouping symbols, and then we're going to square that result. Now it's important that we put them in brackets in here, because if we don't, it will affect our answer. So -3 squared, or -3 times -3, two negatives make a positive, and we get 9 as our result. So we put that in our table of values for our result over here. So -3 squared is +9. But as I said, you have to really be careful, because if we don't put in our brackets, let's delete those and see what happens. And if we press our result this time, we get -9. And what our calculator is doing is it's squaring the 3 first, so 3 squared is 9, and then multiplying by our -1 out the front there, and we get -9. And that's an incorrect answer. So you really have to be careful with negative numbers. So make sure that when you're substituting in, we put them in our grouping symbols or brackets, because that tells us it's -3. And we're multiplying it by -3, so -3 times -3 gives us our +9. So really be careful when we're doing that. So let's do the same thing, and we're going to substitute in -2 squared. So let's delete our 3 and put our 2 in and square it, and we get +4. And we can do a similar thing with the rest of them. So we put in our -1, square it, we get +1, and we're completing our table of values as we go. Well, 0 squared is just 0, 1 squared is 1 times 1, which is 1, 2 squared is 2 times 2, and 3 squared is 3 times 3. So you notice I didn't use my calculator for that, and I'll move that out of the way now. So we've got our table of values, and what that means is we're then going to plot these points. So -3, 9, -2, 4, etc. on a Cartesian plane, also known as a number plane. So here's a Cartesian plane, and we're going to plot all of those points. So -3, 9, so across -3 up to 9, which doesn't show on my Cartesian plane, and -2 up to 4, -1 up 1, 0, 0, across 1 up 1, across 2 up 4, and then across 3 up to 9. So we'll plot all of those points, and there we go. I've just adjusted my Cartesian plane so those points fit on there now. So as I said, -3, 9, -2, 4, etc. And then what we can do is we can try and get a more accurate result by substituting in different values to see what happens as we get closer in here. So we could do half, so substituting x is a half, and a half squared is a quarter, and plot all of those points in between there if we did all that substitution. And this is what our result would be. We get a smooth curve of a parabola. Not a series of straight lines, but a smooth curve of our parabola here. Okay? And as we said there, it's not a series of straight lines. So to get all of these points in between, I can substitute in negative 1.5, negative 1.8, negative 2.2, and get all these answers, which is what this line or curve actually shows. It's a series of results that we substitute different x values in to get our results, our y values. Okay, so now let's have a look at y equals ax squared. Let's have a look at what this a at the front here, this coefficient of x squared, which is multiplying that x squared. So what we're going to do is this a value actually multiplies all those answers we got, the 9, 4, 1, 0, and so on. So this a value actually multiplies all of those answers. So let's see what happens if we look at y equals 2x squared. Well, again, we could complete a table of values and take all of those answers we had before of 9, 4, 1, etc. and multiply them by 2. And now we get 18, 8, 2, 0, 2, 8, and 18. Again, we could use our calculator. So let's just have a quick look at what we could do there. Let's clear all of that. And we could have 2 times, remember putting in our grouping symbols, negative 3, and then square it, and you'll see that we get our result of 18. So again, I was just showing you quickly what we could do on our calculator, making sure you be careful with the negatives when you're substituting. And then we go and plot those points on a Cartesian plane. This is our original one. Okay, the y equals x squared. And now we're going to have a look at what y equals 2x squared looks like. So when we plot all of those points, negative 1, 2, negative 2, 8, negative 3, 18, which doesn't fit on our Cartesian plane, etc. We get a parabola that looks like it's steeper because these answers are growing quicker. So then this part of the parabola actually shows how our answers are going. Alright, I'm going to do a similar thing with y equals 3x squared. So it takes all those answers from before and multiplies them by 3. So this was our original y equals x squared, the lighter one. Then this was y equals 2x squared. And then this darker one here is y equals 3x squared. And you can see how the parabola seems to be even steeper again. Okay, and we call that the dilation. So as a increases, the dilation of the parabola changes. So the parabola becomes steeper. So what happens if our value that we're multiplying here becomes less than 1? Well, we can substitute. Let's have a look at, first of all, y equals a half x squared. Again, completing a table of values and using our calculator, we get our results, multiplying all those original values of 9, 4, and 1 by a half. And we get our results there as decimals. And again, we can see here that this is our original, negative 1, 1. And this is the y equals a half x squared. And you can see the dilation has changed again. And it's actually opened up the parabola more. Okay, so as a became less than 1, or as a becomes smaller, it's opening up that parabola more. So what I'm actually going to do now is we're going to have a look at how a actually changes the dilation of the parabola using a program called Geogebra, which is a very good curve sketching program. So I'm going to call that up, and we're going to have a look at what that actually looks like. So here's our most basic parabola. If you look over here, y equals x squared. My a value is 1, so that's 1x squared, and we know we don't need the 1 out the front. And we're going to have a look at what happens when A becomes bigger. So as A increases, you can see the dilation of the parabola changing, and it's actually becoming steeper and steeper. So there's y equals 4x squared, so you can see that when A is 4, we've got y equals 4x squared, and how that's becoming a steeper parabola. So the parabola seems to be closing up. Okay, and so we can go back to A equals 1, our most basic, y equals x squared, and then again, as A becomes smaller, we get the dilation of our parabola opening up more. Okay? So now that we've looked at that, what actually happens if A is a negative number or even 0? So again, I'm going to open up the Geogebra program, and we've got here again our parabola and our A value. We're going to actually have a look at, first of all, what happens when A becomes 0. So we notice the dilation change there. And I can even make it our A values, instead of being to 1 decimal place, I can make them to 2 or 3. But this would make things a lot quicker. So let's have a look at what happens when A is 0. So I'm going to get y equals 0 times x squared here. And when you multiply something by 0, then our answer is going to be 0. So we get y equals 0. And y equals 0 is a horizontal straight line, which is actually the x-axis. So we can see there that there's our y equals 0. So let's make it positive again. So it's positive, and now it's become 0. So what do you think will happen when A becomes negative? Well, it actually makes all our answers negative, so all our y values will now be negative, meaning that our parabola is now upside down. And again, as I increase, or should actually say decrease, these A values, because they're getting less and less, but make them a larger negative number, then the dilation of our parabola changes and becomes steeper and steeper again. Okay, so that's just showing you what happens when A is both negative, 0, and positive. It changes the dilation, and also whether it's a normal parabola or an upside down parabola. So now that we've seen that, we can see that when A is negative, the parabola turns upside down. So we get it looking like that. And we actually call it, so we can differentiate between the two, we call that concave down. So when the parabola is upside down, we call that a concave down parabola. And obviously when it's its normal way, it's concave up. So there's some new terminology for you: concave up parabolas and concave down parabolas. So concave down occurs when the A value is less than 0, in other words, when A is negative. So let's have a look in summary, what we've basically just come across. When A is a positive number, so when A is bigger than 0, we get our concave up parabola. And as A changes, so does the shape of the parabola. Its dilation changes. So that was a new word for us too. So when A became bigger, it became a steeper parabola. When A became smaller, the parabola opened up more. And then when A was negative, we have a concave down parabola. And again, as A changes, the dilation of the parabola changes also. You'll notice with all of these that the vertex, okay, where the parabola starts to turn around, the vertex of all these parabolas is the point 0, 0, which is the origin. Okay, that will happen with all of those that are in the form y equals ax squared. And something else to note too is that the parabola is symmetrical about the y-axis. So this y-axis here, for all of them, is actually an axis of symmetry for them all. So just something to keep in mind, that parabolas are actually symmetrical. Not always about the y-axis, and we'll see some later on in other videos where it is not, but they are actually symmetrical about where the vertex is. Okay, so what you now really need to do is to practice sketching all these, not all of them because there's an infinite number, but sketching a whole heap of different parabolas in this form so that it makes it easier. You can start off with a table of values, and then after some practice you will be able to do them without a table of values. So the more that you practice and practice again and practice some more, the easier sketching parabolas of the form y equals ax squared will be. So I hope you found this useful. I'll do some other videos on some other parabolas or quadratics later. So what you need to do is then practice, and hopefully you'll be able to get or master these type of parabolas. So thanks for watching.